Network is everywhere. Graph presents a powerful data structure to model the relationship among entities in the real-world networks, such as internet, social networks, and online transactions. Dense subgraph detection problem is very popular in practice. In the web graph of the Internet, emerging trends detection aims to discover the hot topics that are growing in interest and utility over time. In the social network, community detection targets to extract tightly connected subgraphs in the networks. In online transaction networks, money laundering detection tries to identify the malicious identities that involve in the money laundering activities. How can we find the densest subgraph in the network? There are lots of works have been proposed in the literature, such as local graph clustering, directed Laplacian, asymmetric Laplacian, co-clustering and so on, while many existing works focus on the vertices and edges, with the first-order Markov chain as the underlying model. Sometimes, high-order network structures may play a more significant role than edges and nodes in many high-impact domains. For example, the emerging trends detection. In the web graph of Internet, the star-shaped structures showing in a short burst may indicate an emerging trend or hot topic. In other words, by exploring the dense subgraph that contains rich star-shaped structures helps us to find the emerging trends on the Internet. Another example is community detection on social networks. In social networks, triangles have been proven to play the fundamental role in understanding community structures. Thus, by identifying the dense subgraphs contains rich triangles helps to detect communities in social networks. The last application is money laundering detection. In transaction networks, directed cycles might be red flags for potential money laundering activities. Also, by exploring loop-shaped structures helps to identify the malicious identities that involve in money laundering activities. What if you can solve all the problems and find the dense subgraph that contains rich user-defined structures on a given network in polylogarithmic time? Will it be cool? With HasBlock you can. HasBlock stands for High-Order Structure Preserving Local Cut. For better illustrated our framework, here is a simple demo. Suppose the user-defined network structure is 3-node line, and the initial vertex is node 0. Our framework will conduct high-order random walks to locally explore the user-defined network structures in the neighborhoods of node 0. In the end, HasBlock will return a dense subgraph that contains the rich 3-node line. With HasBlock, you can explore any user-defined structures of the given networks with high flexibility and solve real problems in various domains. In our experiments, we show that the effectiveness of HasBlock by comparing 5 state-of-arts on datasets in various domains, the scalability of HasBlock regarding the size of networks and the lower bound volume of returned cluster, the parameter sensitivity of HasBlock regarding the upper bound conductance. Please make sure to check our paper and open source code on the author's websites.